Was bardzo serdecznie na prezentacji dotyczącej Infra as Code. Ja nazywam się Bartłomiej Czudek, jest tutaj Daniel, jest i Grzegorz. Wszyscy w trójkę pracujemy jako architekci w Capgemini i będziemy chcieli zademonstrować Wam benefity, które płyną z koncepcji Infra as Code. Na tyle się znamy, że chyba możemy troszeczkę więcej technikaliów tutaj zdradzić i jak gdyby technicznych rzeczy. Pierwsze pytanie, na które chyba znam odpowiedź, ale zadam, czy mieliście styczność już z konceptem Infrastructure as Code? Super, świetnie. No to będziemy rozwijać ten temat, zobaczycie. Ty miałeś? Okej, super, przepraszam. Będziemy rozwijać ten temat i opowiemy troszkę więcej, jak my podchodzimy do tego, taką formą troszeczkę pół żartu, pół serio. Przygotowaliśmy dla Was grę. Przygotowaliśmy dla Was grę oraz takie pudełko z takimi mechanicznymi urządzeniami, które będziemy w ciągu naszej krótkiej prezentacji Wam tutaj demonstrować. Gra jest dosyć specyficzna, można sobie grać przy pomocy pada. Jest to gra, której nie napisaliśmy, to nie nasza gra, to gra, która jest dostępna za darmo w internecie, a to, co my żeśmy zrobili z tą grą, to wykonaliśmy tak zwany Modernizing Traditional Applications, czyli wzięliśmy kod tej gry i umieściliśmy ją w kontenerach, a następnie wypchnęliśmy do chmury. Jest to nowy koncept, który teraz jest bardzo popularny wśród wielu firm, aby stare oprogramowanie, czy też oprogramowanie, które działa na starych systemach operacyjnych, konteneryzować i wynosić do chmury. Nasz jak gdyby setup infrastruktury, który tutaj mamy, mieści się wszystko w Azure. Mamy tutaj rejestr kontenerów, mamy również Azure Container Kubernetes Service, czyli taki serwis dostarczany przez Microsoft na platformie Azure, który wspiera koncepcję konteneryzacji i orkiestrator Kubernetesa. Menedżery 3 nody, na tych 3 nodach działają nam kontenery odpowiedzialne za tą aplikację, czy też pody, lepiej może tak powiedzieć, w przypadku Kubernetesa mamy pody odpowiedzialne za tą aplikację, a także tutaj działa nam Grafana i Prometheus, czyli jedne z takich bardziej popularnych obecnie darmowych, a zyskujących coraz większą popularność narzędzi do jak gdyby prezentowania logów infrastruktury czy aplikacji. To właśnie jest tutaj widoczne. Nasza gra, która została jak gdyby zdeployowana, w którą możecie grać, działa sobie właśnie cały czas w chmurze i naszym celem tutaj będzie zademonstrowanie Wam, jaka jest siła i jaki jest jak gdyby tutaj potencjał w koncepcji Infrastructure as Code. Żeby jak gdyby to zademonstrować, potrzebuję ochotnika. Jako że jesteś najbliżej, to mam do Ciebie prośbę w takim razie. Czy byłbyś tak uprzejmie nacisnął ten czerwony przycisk, który jest tam na górze? Tak jest. Raz, prosimy. Dokładnie. Dzięki. Na razie jak gdyby nic nie widać, żeby się coś wydarzyło, ale my dokładnie wiemy, co się tam dzieje pod spodem. Otóż ten czerwony przycisk to jest przycisk, który niszczy naszą infrastrukturę, który symuluje dokładnie upadek jakichś rzeczy na produkcji. W naszym przypadku jest to zniszczenie tutaj kontenerów, które działają na produkcji. W międzyczasie uruchamia się właśnie to zniszczenie, czekamy na jego wynik, za chwileczkę powinna gra przestać działać. Dlaczego zaczynamy prezentować koncepcję Infrastructure as Code od, nazwijmy to, takiego dramatycznego przypadku, a mianowicie dlatego, że mamy świadomość, że w dzisiejszych czasach, kiedy infrastruktura jest tak strasznie dynamiczna i tak strasznie płynna, ważne jest to, aby móc tą infrastrukturę bardzo szybko odtwarzać. I właśnie i tu mamy przykład, nasze 3 nody zostały całkowicie położone, gra nie działa i jak gdyby dla nas ważne jest to, że mając zeskryptowaną i jak gdyby całą infrastrukturę i wdrożony pipeline Continuous Integration i Continuous Deployment, możemy w dowolnej chwili jak gdyby bardzo szybko tutaj jak gdyby przywrócić do działania z powrotem tą grę. To, co się u nas dzieje i to, co będziecie za chwileczkę mogli zobaczyć, to jest pewien pipeline, który nazywa się właśnie Continuous Integration i Continuous Delivery. To jest coś, co mamy wdrożone u nas w Capgemini i właśnie chcieliśmy zademonstrować to tutaj na tym przykładzie. Mianowicie, no, jesteście panowie techniczni. O, przepraszam, witamy. Czy mam mówić po polsku, czy mam się przerzucić po angielsku? Okay, shall I speak English? All right, okay. So just a quick intro, because you joined us like 5 minutes later, so just to explain you what you're looking at. So what we have here, we took a game from a company who shared it like on a license that we can use it. And what we did, this game was old, and what we did, we containerize it. So we take the source code of that game and put this game into the containers. Are you aware of the concept of the containers? Have you heard about this? Okay, so just let me quickly say a few words about this. So for the purpose of like a very simple of this presentation, you can think about containers like a very, very lightweight virtual machines. They are not technically virtual machines, but they act and pretend like a virtual machines. You can spin these containers like in thousands and millions, very flexible. You can destroy them, and they are like a fluctuate. You know, if there is a peak, if there is a need to have more containers, more services served, you can spin it up more and more. The concept behind the containers is that each of these containers served one purpose. They provide one simple service. The pioneer in this containers concept is Netflix. So I think everyone is using the Netflix. So entire infrastructure behind the video on demand, which Netflix is providing, is running on the containers. They even introduced something which we demonstrated here because our game was running, but I asked our friend for help, and he pushed the red button you can see over there. It's like a simulation of disaster on production. So what actually happened, the game which was on the TV visible in a moment is no longer available. The 3 nodes on which this game is running has been destroyed. So these 3, and our game is no longer available. What the modern approach to the infrastructure means is that companies and software vendors are trying to embrace the failure. They are not trying to avoid it, they're trying to embrace it. So the Netflix, for instance, has got some application called Chaos Monkey. And this application is every day around 1 Pacific time AM, it's running and by random disables services, disables container on the production to prove that this application is failure, it can embrace the failure, will be still responsive. So one of the I would say first step in order to implement such a failure embracement is to have a very good infrastructure defined using the code. So what is happening here is that we entire infrastructure, so all these servers which are running on Azure, all the code which we have are scripted. And what we can do, we can destroy everything and rebuild it from scratch like that. I mean, like it's using pushing one button and everything will happen automatically. For this purpose of the presentation, we haven't destroyed everything because it would take like a 15 to 20 minutes to reprovision entire game, but we just destroyed 3 servers using that red button, and it has been this 3 server has been destroyed, and as you can see, a nice indicator that game is no longer available is on the screen. So what we would like to demonstrate to you right now is that we can easily restore that game back to operational. So what you can see over here is one of the things that we introduce in few our companies and our clients and projects is continuous integration and continuous delivery pipeline, which is very tightly, I would say, connected with the infrastructure as code. So what is happening here, there are 2 tubes. The first tube is like a process, and the second one is our implementation for this particular project. So what we can do here, the programmer or anyone can provide a new update to the code. There is a trigger. This trigger what will happen? It will prepare a new package of the application, and it will deploy to the production. Here what we can do is we can easily schedule, using the new code, we can schedule building the application to the container pushing it to the container registry and run it on the Azure Kubernetes service. So this is something what we can deliver. And in order to trigger this, as there might be many ways of triggering that process. The first one might be, approval in a service now, for instance. The second one may be submitting a new change to the repository, new code. And in our case, it's going to be quite fun. So Grzegorz, can I ask you to actually trigger to restore the new? Okay, yeah. The thing is that I'm humble and I don't want to ask our guests to pay for it. Okay. Yes. Yes. Is there anyone? Is there any volunteer who would like to have fun? Yeah. Okay. Yeah. You just try to fix it. Okay. So the trigger we implemented for this, you can push. Yeah. You can put the 5 zloty and press the red button, please. Yeah. All right. Yeah. Again, this time a red button works in a good way. So what is going to happen right now is going to trigger the restoration of the game. So in the meantime, because it's going to take like a few minutes, I'm going to tell you more about the infrastructure as code itself, the way how we observe and how we see how the infrastructure is evolving, looking at our customers. So for this purpose, we create kind of an arrow which demonstrate where various of our clients, various of our projects are when it comes to the modern approach to the infrastructure. So what you can see over here is like a first stage of the maturity of the infrastructure is something which is called imperative infra. In that stage, companies' projects tends to define the infrastructure using like a very first scripts, very manual work in order to set up the servers, virtual machines, in order to connect the virtual switches and define the network. Then usually the next step of the maturity of infrastructure is something we call declarative infra. And this is good thing because in this case, what is happening is that the project has got defined as scripts which describes the state how the infrastructure should looks like. So we've got a set of the scripts where we say this is the configuration of the virtual machines we want. These are the configuration of the network we want. And then we provide the scripts to the specific applications and say run it and deliver it. And this is exactly what is happening right now, if I'm correct, Daniel, yes? Are we going? What is happening right now, we've got set of the scripts which we send out to our build machine, and if Daniel will refresh the website, the game should be restored successfully. So we reprovision all the VMs beneath all the services, and we manage to deliver the game back. The next step is the immutable infra. So immutable infra concept is that, I think that's the most important definition of it, is a favor rebuild over patching. So the so the projects are no longer so the projects are no longer approaching the infrastructure in a way that they are trying to patch it. They are trying to fix it. No, they rebuild it from scratch. So if something is not working, we can easily, destroy everything and rebuild it from scratch. And this is exactly what happened with our game, because we didn't try to, start, patching something, trying to find the way how to, fix something on these VMs. No, we destroy them and rebuild them from the scratch. And the fourth, I think, future of the infrastructure is the infrastructure driven by artificial intelligence. So the infrastructure which can actually predict how much resources will be required in the future, how the infrastructure will be better aligned in the projects. Also, something which is very important, we see that there is also a green infrastructure, which means that the customers are aware what is the carbon footprint of their infrastructure, of their applications on the environment, trying to save some energy, trying to save some space in order to be more environmental friendly. One of the way that we try to approach in Capgemini the modern infrastructure is something that we map most of our projects into something which is called Cloud Native Computing Foundation. So this is a concept of the non-profit organization which says that there is already 578 technologies, various technologies, which is related to the infrastructure and writing the native application on the web. A native application for cloud. What we are trying to do is we are trying always map the that landscape, our projects to that landscape, to better understand how actually the projects are evolving, how these projects are, which kind of technologies these projects uses, and we as a Capgemini also trying to learn our teams and try to build our teams around this cloud native computing foundation, because we clearly see that this is a near future and something which is evolving. A different way of demonstrating this picture, which sort of demonstrate how many technologies are available right now on the market, is the picture that the cloud native itself provides. As you can see, there are lots of technologies right now, and we are trying to pick the most important one to be ready for delivering the service for our customer. One of the example with the infrastructure as code and with this landscape is the company and very interesting project we recently delivered. This is the company which has got 120 cruise ships in the United States, ships where 5,000 people spend their week cruising around the Caribbean islands and enjoying the views and having like a holidays over there. This company decided that they're going to introduce something they called Ocean Medallion, so like a wearable device which they will be able to use in order to open the cabins, in order to order some food, drinks, or play games in casinos. To deliver such experience, such digital experience, they ask us to equip each of the ship. We started with 2 already, and then we will gradually go with this. Equip each of the ship with entire full stack of the servers. Using the techniques we demonstrated to you, like infrastructure as code and all of these technologies demonstrated here and mapped to the cloud native foundation, we are able to provision each of the ship having the servers on the ship itself, which are connected to power and connected to network. We can in a 45 to 50 minutes executing one button, provision with all the bare metal VMware, so bare metal like a hypervisor, configure network, set up 150 virtual machines, connect them, deploy almost 400 services in the containers and various databases, and basically made the ship operational in 1 hour, which is like huge achievement, and we are very proud of it, because this is something we wouldn't be able to deliver without the concept of infrastructure as code. And as said previously, we can destroy the entire server and rebuild it from scratch, each of the ship. So that's it when it comes to the infrastructure as code. And when it comes to our game, do you have maybe some questions to this? Nothing. Okay, so thank you very much. I hope that you enjoyed the scene, and we'll be here around, so in case you have some questions, don't hesitate and